Today we're going to talk about another law that lets you solve triangles that are not right triangles. You can solve right triangles fairly easily using your trig functions. We've got the law of cosines that helps us solve non-right triangles. And now the law of sines is going to be another way to find missing sides and angles for non-right triangles. If you remember when we talked about areas, we had the formula for the area that was 1/2 BC sine A. And A, B, and C are just usually the letters we use, but as long as you have two sides and the included angle, then you can find the area. So we're going to use that fact to derive the law of sines. This one's pretty easy. So first of all, let's say we know sides D and L and angle P. Then the area of this triangle would be 1/2 DL times sine of P. Now, if you knew a different angle and two sides, then you could find the angle using those. And the angle of the triangle is not changing, right? So this is equal to the area using a different pair of sides and angle. So I could say that's the same as 1/2 dP sine L, all right, because the area is the same no matter which one I use. And then I can also do it the third way and do 1/2 PL sine D. All right, so depending on which info was given, we could have three expressions for the area, all using the same formula, as long as the angle you use is not the same letter as the two sides, right? Angle D needs to go with sides P and L, and then the other two versions of that. So if this is true, which we know it is from our last video, what I want to do is take each one of these expressions in this three-part equation, and I want to divide them all by 1/2 little p, little d, little l. I don't know why I did PDL instead of PLD, but I did. All right, so it's an equation. If you do something to one part, you do it to all parts, and we're fine. So see what cancels. The 1/2 in this first equation cancels. The D and the L cancel. And I'm left with sine P over P. In the second version, the D and the P cancel, and the 1/2s cancel, and I get sine L over L. And in the third one, I get sine D over D. And usually we'll use A, B, and C, so just so it's not confusing when you see it printed, this is the law of sines. Sine A over A equals sine B over B equals sine C over C. And you're not going to use all three parts, but the point of it is you're going to set up a proportion with sine of an angle over the opposite side equals sine of a different angle over its opposite side. So this is going to allow us to solve triangles with different given infos. Remember, law of cosines works well if you're given side, 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 or side, angle, side. If you're given a different version, a different set of three numbers, then this might be the way to go. So let's start with this example. We're going to use the law of sines to find QR. All right, I'm going to call that X because I like X to stand for an unknown rather than two letters like QR. And this is a very simple setup. Sine of 41 over X, because 41 is across from X, equals, now the other side that I have is 35, equals the sine of angle Q over 35. What I'm seeing is that I need to figure out what angle Q is. That's easy though, because all triangles need to add up to 180. So I need to do 180 minus 41 minus 53, which is, let's see, 41 and 53 is 94, which means this one would be 86. should have done that beforehand, but I didn't recognize the fact that I needed angle Q. No big deal. All right. So now that I've got that, I've got 86 here. And now it's a proportion in my calculator. You probably were taught a bunch of different ways to solve this. Cross multiply and divide is one way. However you want to solve, it's fine. But let's get the calculator out and solve this proportion. Okay, so sine 41 over x is sine 86 over 35. The way I'm going to solve it is sine of 41, close my parentheses around 41 degrees, times 35 divided by sine 86. So I'm going with the cross multiply and divide. And I get 23.0. We'll just go to the nearest tenth and call it 23.0. Always look and see if your answer is reasonable. If this is 35, could this be 23? Yeah, it's a little bit shorter. It's not too short, but it makes sense. That's what matters. All right, so a quick, easy little proportion. This law of sines is a quick one. It's a powerful law helping you find missing sides and angles. Let's check another example with maybe a little different info. In that one, I was given angle, side, angle up here. Right? Angle, side, angle. Now I'm given side, side, angle. All right? So if you're given side, side, angle, we're going to find angle x. This is my unknown up here. All right, so let's set up our proportion. Sine of an angle, in this case I know the 58, sine of 58 degrees, over 29, because that's across the triangle from the 58 degrees, equals sine x over 15. All right, so the difference here is my unknown is the argument of sine, right? I just was finding a side length. In this case, I'm finding an angle. So what I'm going to have to do is do my, my cross multiply and divide and then inverse sine my answer. All right, so I've got sine of 58 times 15 divided by 29 equals 0.438645567. So right now, 4386 is equal to sine x. That's not my answer. And you should count on a number between 0 and 1 right here, because sine is never any bigger than 1. And so what I need to do is inverse sine that number. So I'm going to go second sine of second answer and get 26.0 degrees. All right, now that's law of sines to find a side, law of sines to find an angle. There's going to be a future video where this will be detailed, but I need you to write down right now with 2 stars. Be careful. When finding angles, with the law of sines. Double starred, circled twice. All right, make sure that you have that and it's standing out in your notes. We'll learn why on our next video, but just realize when you find an angle with the law of sines, it might be misleading. You're going to have to be careful and check to make sure that your answer is reasonable. And if we look at ours, that x 26 makes sense. All right, so that's the law of sines. It's a nice, easy one, but it can be risky. More details to come. Young, signing out.